All right. So we know y equals e to the x is going up like this. Domain is all real numbers. The range is y is to be greater than 0. What's the y-intercept?
The value of e.
No, that's actually when x is 1, it's at the value of e. So yeah, so this is just 1. When x is 0, okay, when x is 0, e to the 0 is 1. Okay? Now, let's think in terms of our derivative. Okay? For our derivative, what do you notice about all of the tangent lines? Like if I drew that tangent line, or if I drew this tangent line, or if I drew even this tangent line, what do all those tangent lines have in common?
They're positive.
Okay, they all have a positive slope. Alright, the derivative of e to the x is always going to be positive. Alright, because our function is constantly increasing. It's increasing as we go from negative infinity up to positive infinity. Okay? Now, let me point out a couple of things here. Some we've already mentioned, but first of all, notation. There is an alternative way of writing this that you may see. I know you'll see it in your book. You may see it other places as well. I've seen it a few different places. Okay? But another way of writing e to the x is this. X of x. Alright? So y equals exp of x. That means the same thing as e to the x. A second thing is, it goes through the point 0, 1, which you already said. There's an asymptote at the x-axis as we approach negative infinity. And it's above the x-axis. We're always going to have a positive value for both the y-coordinates and for the derivatives. Okay? Now, obviously, all of the different transformations that we can apply to functions, we could apply to this. For example, if we made x negative, it would reflect it across the y-axis. If we made it a negative e to the x, it would reflect it across the x-axis. And obviously we could add to it or subtract from it to shift it around and all that stuff too. Okay? But the reason why this is such an easy derivative to remember is because if f of x is e to the x, f prime of x equals e to the x. Okay? It is its own derivative. Okay? So at that y-intercept, what's the slope of the tangent line? 1. Okay? Because it's going to be the same as the value of the function at that point. Alright? We mentioned already the point 1e, 1, 2.78, and so on. 718. Alright, so here's the point 1e. So what's the slope of the tangent line at x equals 1? It's e. Okay? So that's pretty nice. So as you can anticipate, it doesn't take a whole lot of practice to get this one down. Where it gets a little trickier is the fact that we're going to be using this in addition to our product rule, our quotient rule, and our chain rule. Okay? So once you've memorized that, then we can use it with our product rule, our quotient rule, and our chain rule. Alright? So, looking at this in terms of the chain rule, you can see up here, if we have just an e to the x, the derivative is e to the x. But if we have e to some function power, like here we have e to the negative 3x, okay? You need to see that as a function within a function. The negative 3x is inside our function e to the x. Okay? So, you would take you would leave it the same because the derivative of e to anything is e to anything. But then you would multiply it by the derivative of that exponent. Okay, so in this case here, we have a sum, and the derivative of a sum is the sum of the derivatives, so we can just take one part at a time. You guys know the derivative of e to the x is e to the x. What do we do when there's a constant multiple? Like 2 times e to the x.
Yeah, probably. You just said the 2 for after.
Just save the 2 for after, so we take the derivative of e to the x and then multiply it by 2. So that's just 2 e to the x. That's the derivative of that first portion. Does that make sense, everyone? Okay. Now, we have plus the derivative of e to the negative 3x. Alright, so what we're going to do, at first you take the derivative of e to a power, which is just e to that same power. But now here comes the chain rule. We multiply that by the derivative of negative 3x. So what is the derivative of negative 3x? Negative 3, good. Okay, so our derivative would be 2e to the x minus 3e to the negative 3x. And that's it. Yes. All right. So not too bad. Let's take out some in other contexts here. Here's a context where we're going to need to use the product rule. We have x squared times e to the negative x. Here's a context here where we have to use the quotient rule, e to the 2x over x. Okay? So let's try this, all right? X squared is going to be u, so what's u prime?
2x.
2x. E to the negative x is v. So now we need to find v prime. V prime would be
Negative
e to the negative x, and then times a negative 1. Good. So negative e to the negative x would be our derivative. Okay? Again, I used the chain rule. The derivative of e to a power is e to that power, but then I multiply by the derivative of the exponent, which is negative 1. Now we can use the product rule. Okay? Let's get this up here. Okay, so now the product rule, dy dx, u prime v, so 2x times e to the negative x plus uv prime. So here's plus x squared times, that's ugly, x squared times a negative e to the negative x. Now the same rules for simplifying apply here. Right. So I would rewrite this as 2x over e to the x to make it a positive exponent. This negative I can pull out in front, so it's going to be a minus x squared over e to the x. And then finally, if you notice they have a common denominator, you might as well combine them. So 2x minus x squared over e to the x. And that would be our final answer. questions about what we've done? Okay. Let's try our chain rule, or our quotient rule now. We'll use our chain rule for our numerator. So here's u and v again. What would u prime equal?
2e to the 2x.
Very good. 2e to the 2x. E to the 2x is the derivative of the outer function. 2 is the derivative of the inner function, that 2x. Okay, good. And v prime is just 1. Okay? Why don't you try taking it from there and see if you can simplify the whole thing and get a good answer. Okay. So that's what you got to get when you set it up. All right. If you'd like to simplify that a little bit more, you'll notice both terms in the numerator have an e to the 2x. So you don't absolutely have to, but you could go ahead and factor out the e to the 2x. And that'll be times 2x minus 1, and that's all over x squared. That may make it a little simpler if we were, say, going to take a derivative of the derivative, or do something else with that in an application or something, okay? So, yes?
Could you have factored out the x or no?
The x here?
Yeah. Like take it
No,
out.
because this one doesn't have one.
Okay.
Now, you could have split it into two separate fractions if
Okay.
you wanted. That would be possible, but... Okay. Alright, the last of these, we've done ones where we have the chain rule to find the derivative of that exponent, but here are ones where the e to the x is actually part of the inner function. Okay? So in this case, we have e to the x minus 1 cubed. So the outer function is the something cubed. Alright? So that the derivative of something cubed is 3 times that something squared. But now we use the chain rule, and we've got to multiply by the derivative of the inner function. So what would that be? E to the x. Okay? Derivative of e to the x minus 1 is just e to the x. So, of course, we can make that, rearrange things a little bit. 3e to the x times e to the x, not e times x, e to the x minus 1 squared. Alright, and then the really fun ones, like this last one, we have a chain rule within a chain rule that we're going to have to handle. Okay, before we do anything though, let's rewrite this. How could I rewrite this function? David?
2e to the negative x plus 1 to the negative half.
Very good. to the negative 1/2 power. So now you see we have something raised to the negative 1/2 power, so that's our first chain rule part. Then when we're doing the derivative of the inner function, we're going to have to use the chain rule with that e to the negative x. Okay? So, what's the derivative of something to the negative 1/2 power? Negative 1/2 times the something to what power?
Negative 3 over 2
Yeah, the negative 3 over 2 power.
times.
Okay, so that's the derivative of the outer. Now we need the derivative of the inner function, which is... Okay, good. 2e to the negative x would be the derivative of the outer function. Okay, the 1 has a derivative of 0, but then you guys correctly identified we need a negative there because we need to multiply it by the derivative of the exponent, which is a negative 1. Okay? So now simplifying, and this is partly why we simplify, is because this actually simplifies a bit. Okay? First of all, the negative 2, negative 1/2 cancel out. These all have negative exponents, so it's 1 over 2e to the negative x. So it would be 1 over 2 over x, 2 over e to the x, plus 1 to the 3/2, and this is e to the x in the denominator as well. You don't need to try to simplify that so it's not a complex fraction, because it's inside the 3/2 power. So, alrighty, have a good day. We'll see you tomorrow.